Hi everyone, I'm Cheryl. In this problem, we're going to be looking at several higher order partial derivatives. We'll be looking at fxyy, fyxy, and fyyx. And we're going to see that they're all equivalent to each other. Okay, so let's go ahead and get started. In order to find higher order partials, I have to start with the first partials. And for each of these, notice that I do need to have a first order with respect to x, and then on these other two, I'll need the first order with respect to y. So I'll need both of those. So let's go ahead and look at the derivative, the first partial with respect to x, of x, y, z. Now when I do that, remember, since I'm taking the partial with respect to x, I'm going to treat y and z like they're constants. So if I treat y and z like they're constants, that means that y times z will be a constant, and the sign of yz will act as a constant. So this derivative is going to be the derivative of e to the minus x, which will be minus e to the minus x, times the constant sine yz. All right, so that's my first partial with respect to x. Again, to do these mixed partials, I'm going to need the first partial with respect to y. So let's go ahead and do that now as well. So I'll take the first partial with respect to y of x, y, and z. And again, I'm going to be treating, in this case, the x and the z as if they're constants. So if I'm treating x and z as constants, then that means e to the minus x will be treated as a constant. So I can just pull that out as a constant multiple. And now I'll take the derivative of the sine of yz, which is the cosine of yz. But remember, I'm treating z as a constant. So what's the derivative of y times z with respect to y? It's just z. So this partial is going to be z e to the minus x cosine of yz. Okay, now let's go ahead and look at a second partial. For this first piece, I know I need to take the derivative with respect to x, but then with respect to y. So let's look at the mixed partial fxy of xyz. And when I do this, because I'll be differentiating with respect to y, I want to treat x and z as if they're constants. So I'll be taking the derivative of my first partial with respect to y. All right, so let's see. If I'm treating x as a constant, that means the minus e to the minus x can be treated as a constant as well. So that's minus e to the minus x. The derivative of the sine yz will be cosine of yz. But remember, I'm treating z as if it's a constant. So when I use the chain rule, the derivative of yz is just going to be z. So my mixed partial fxy is going to be minus z e to the minus x cosine of yz. Now, for my very first higher order mixed partial, I want fxyy. So I'm going to go ahead and take the derivative of this with respect to y. So I'll have fxyy of x, y, and z. And I'm going to be treating the x and the z as constants because I'll be differentiating with respect to y. So here's fxy, so I need to differentiate this with respect to y. So because z and x are constants, this whole piece right in here is just a big constant. So that'll be minus z e to the minus x. And when I differentiate cosine, the derivative is minus sine of yz. And I need to take the derivative of yz. Again, I'm treating z as a constant, and I'm differentiating with respect to y. So this will be times z. And I get a positive z squared e to the minus x times the sine of yz. And that's the first of my higher order partials that I'm interested in. All right, the other two are coming from a first partial of y. So I'm going to start with my first partial with respect to y. The next piece I'll look at is the partial fyx of x, y, z. And when I do this, because I'm differentiating with respect to x, I want to treat the y and the z as if they're constants. All right, so here's the partial with respect to y, so I need to differentiate this thing with respect to x. Okay, so the z is a constant, and I know that the y in the z is a constant, so the z and the cosine of yz are both constants, and I need to differentiate e to the minus x, which is going to be a minus e to the minus x power. This is going to give me a minus z e to the minus x cosine of yz. Now, notice that what I need for one of my mixed partials is fyxy. I already have fyx, so let's differentiate this derivative with respect to y. Because I'm differentiating with respect to y, I'll be treating the x and the z as constants. Okay, so this is fyx, so I need to differentiate this piece with respect to y. So that means that the x and the z are constants. This whole piece in front, the minus z e to the minus x, is all a constant. The derivative of cosine is minus sine of yz. And then I have to take the derivative of the inside piece, and because I'm treating z as a constant and I'm differentiating with respect to y, I'll end up with a z here. When I combine this together, my negative and a negative become positive, and I have a z squared e to the minus x times the sine of yz. Now let's take a look at this. Here is my first mixed partial, z squared e to the minus x sine yz, and here is the second one. They're exactly the same thing. So far, so good. All right, the last piece. I need to find the mixed partial fyx. So I'm going to start with my first partial with respect to y. And if I look for fyy of xyz, again, if I'm differentiating with respect to y, I'm going to treat x and z as if they're constants. And I'm going to start with my first partial with respect to y and differentiate it with respect to y. Okay, so that means that the x and the z are constants, so z e to the minus z e to the minus x is treated as a constant. The derivative of cosine is minus sine of yz. And by the chain rule, I need to take the derivative of yz. Z is being treated as a constant, and so I'll just have a z here, and I end up with a minus z squared e to the minus x sine of yz. Okay, one more step. I need to find the mixed partial fyyx of x, y, z. I'm differentiating with respect to x, which means that the y and the z are treated as constants, and I'm taking the derivative of fyy with respect to x. So if I do that, my z is a constant, so minus z squared is a constant. Because y and z is a constant, so is the sine of yz, and the only thing I have to differentiate is e to the minus x, which is minus e to the minus x. And when I simplify this, I'm going to end up with a positive z squared e to the minus x sine of yz. And if you notice, it's exactly the same thing that I got for my other mixed partials. I hope that was helpful. Thanks.